Yeah.
Well, thank you for coming to this presentation. We're going to be talking about strong authentication for supply chain and SCADA systems that impact the bottom line. So that's a lot of word, but really what we're going to be talking about is how Schneider had implemented YubiKeys, and a little bit this is like a history of what we've been doing with them over the last, like
since 2016, somewhere in there, yeah.
Yes, and so a lot of this is going to be an education of the complexities of these environments and how this all sort of comes together and what you have to think about in an OT environment, and not necessarily, FIDO per se, but this is like going to talk about how do you take this and think about with FIDO. And
so go back a slide.
I don't want to go back there.
Yeah,
but first off, who are we? So,
go ahead.
I'm David Treece. I'm solution architect at Yubico, and this is Chad.
Hi, I'm Chad Lloyd. I'm the director of security engineering at Schneider Electric.
So I'm going to hand this over to Chad after we talk about this, but as we said, is that this presentation is really to understand a lot around OT and how the complexities of that and the history of how to put in MFA and what needed to be done there. So the goal is that from this, to understand critical systems a little bit better, and also even think about the way FIDO would be implemented in this space. And a lot of these are open questions and not complete solutions. So there's a lot of complexity here, and this is really important to look at this and how to protect these areas. So to that, the agenda, talk about the OT landscape, the supply chain security use cases that Schneider has in existing MFA solutions, as well as not just MFA, but how you do that supply chain, and then questions around moving forward to FIDO. And with that, I'm going to hand this over to Chad.
All right, thanks, Dave. All right, so let's start with the obvious. Today, if you think about critical infrastructure, it's certainly becoming an increasing target, right? We see this in the news. We probably experienced in some ways for ourselves with the challenges in Ukraine. They're, of course, seeing it as well. So we know that critical infrastructure is a target. Critical infrastructure is basically controlled by OT networks, and we're going to talk about OT a bit in this presentation, just to kind of give you an example of how OT, operational technology, is completely different from IT. And a lot of us, including myself, come from IT backgrounds, right? So let's talk about OT and IT and how this works with FIDO and multi-factor authentication, and that's where we're going. So you can see here on the screen, there's a couple of different examples dating all the way back to 2010. Probably many of you have heard of Stuxnet. Stuxnet's a great example of a malware that caused some really disastrous consequences. Okay, and one of the biggest things, they thought they were safe because their system was air-gapped. You've probably heard that over and over before, right? These networks, they're air-gapped, so they're totally secure. You don't have to worry about anything because they're air-gapped. Well, Stuxnet proved that wasn't the case. It's estimated or theorized that Stuxnet was able to bridge the gap. We don't know if it was a USB key drop. We don't know if it was an engineering laptop that was plugged in at a hotel and then walked in and plugged into the control system. But ultimately, that air-gapped network didn't stop it, right? Which is why we're here today. Like David said, we have open questions. This isn't an answers talk, okay? We're not telling you we figured it out. We're telling you here's some challenges with critical infrastructure, and we want the community's help in addressing this, okay? So let's talk a little bit about OT networks and how that differs from IT. To me, this is a slide I use all the time in internal presentations. I use it with customers. But ultimately, what you'll find is that IT networks are very commonly misaligned with what an OT network as far as priorities are concerned. You can probably resonate with this pretty well, right? CIA, we've been drilled in CIA, confidentiality, integrity, availability, when you think about your traditional IT network. However, OT networks, that's controlling the cyber physical space. An OT network, by definition, means that we have something, some software that is able to control hardware that moves something, that energizes something. Kind of the thing that I explain this with is in the IT system, if something really bad goes wrong, somebody might get fired. In the OT system, if something really bad goes wrong, somebody's either injured or killed, right? Because they're managing physical things. So therefore, there's quite a heavier barrier, a higher bar, if you will. We have to secure these systems. When you think about the different priorities in play, safety's always number 0, right? That's always at the top. And then you have availability, integrity, and confidentiality. Now, that's not to say that confidentiality is not important in an OT system. Let's think about a manufacturing facility, maybe it's pharmaceuticals. How they can manufacture a drug and how long they leave on certain parts of their process, you could use energy data to literally infer trade secret information. All of that to say, confidentiality is important. But typically in an OT world, availability is more important. And we have to consider that when we think about fallback mechanisms to authentication, right? How FIDO, today, for instance, we're using UBOTP. Our move to FIDO, we have to consider this. What is that fallback? And sometimes that fallback is more important than the original login. Now, just when you're thinking about terms, you might hear in the OT world reliability. You'll hear safety, reliability, and confidentiality. Don't let that confuse you. That's really just availability and integrity in the background. Okay? So, good news, we have this thing called IEC 62443 or ISA 62443. We all love standards, right? That's why we're here. We all love standards. And the thing about 62443, at least in our world, in the OT world, is we can rely on this globally because it is a true ISA and IEC standard. There's not a lot of standards that you can say that have been adopted globally. The thing about this is that for our customers that are working in critical infrastructure, think about healthcare facilities, data centers, that would be critical infrastructure. Some of these massive financial data centers go down, we're in a heap of trouble, right? That's going to cause an economic crash. Potentially. So again, critical infrastructure. IEC 62443 helps those customers define what their security requirements are because those customers may not be familiar even with what multi-factor authentication or mutual authentication, et cetera. But what they can look at is a standard and say they want to be security level 2 or 3 or 4. From a multi-factor authentication standpoint, notice that SL3, it actually requires, the laser doesn't work. SL3 actually requires multi-factor authentication. So now we have a standard that is instructing critical infrastructure customers to institute MFA, which of course we want to drive them to FIDO. Okay? So let's talk a little bit about the devices that we use in critical infrastructure and how this differs from what you may see in the IT counterpart. Okay, the first thing is the devices that you'll see in this world, in these critical infrastructure applications, substations for instance, they're similar to flight data recorders. They're also kind of similar to the DVR that you have probably on your television, right? So instead of looking at a stream of video, they're looking at the waveform that's captured from the power line. You think about the sine wave, right? Well, when we think about that sine wave, we're probably thinking, that's voltage going up and, well, yeah, that's true, but there's also harmonics, there's frequencies, there's over 1,000 different quantities that these devices capture, and they're capturing at the sub-millisecond range. A very high sample rate. And the idea is that when something happens, let's say it's a lightning strike, it actually has this window of time that it's captured lightning strikes. It can rewind and it can show you the various things that were happening on that power line before and then after the event. So then you can start to deduce what protections need to be in place, et cetera, et cetera. My point here is that these devices in OT are very complex. They're not like the circuit breakers in your house that just trip when there's an overcurrent condition. It's much more complicated than that. These are similar to PLCs, but in some cases even more powerful. You'll notice some medium voltage. By the way, medium voltage to us is in the thousands of volts, right? So medium voltage arc flash, so now we're talking about safety. Arc flash is when there's some type of a short on the electrical network and it's possible that a person is too close and they experience that molten metal, right? So it's a safety condition. Power quality monitoring, talking about harmonics, noise on the wire. And then finally, we have these low voltage circuit breakers. Now we're like in the 480 volt, 220 volt situation, okay? So these devices, again, have multiple CPUs. Like the one on the right, it has one CPU devoted to looking at the trip curve for the circuit breaker and tripping the breaker, a separate CPU for all of the user interface, all the communication stack, the authentication. So therefore, if something were to slow down that second CPU, that first CPU is not going to get rushed to the point or resource spike to the point that it couldn't trip the breaker. So just to kind of give you an idea of how advanced some of these devices are. So let's talk about that these devices require high security. From a supply chain standpoint, which is we're going to talk about in just a second, also from an authentication standpoint. I include this slide just to kind of give you a view of what this looks like from an end user's perspective. Think about those big control rooms. If you hadn't seen one in person, you've seen them in the movies, where think about your local utility is going to have these big screens on the wall and they're looking at the power flow, right? That's what you see here on the left-hand side. That's called a single line diagram. It's showing power flow through circuit breakers. You can click on one of those circuit breakers and it'll bring a pop-up up on the screen. And if you look at the bottom left-hand corner there, it says open and close. It does exactly what it says. It's a remote utility to be able to open and close that circuit breaker that could be miles away, especially if it's on an electric utility. With these YubiKey devices, we now have instituted a confirmation of control. You plug in the YubiKey, when you hit open breaker, you're also going to authenticate with that YubiKey, and that makes it possible to make sure that the person that instituted the control is in fact the person at least that maintains or possesses that YubiKey, because these applications will stay open all the time. It's rare that someone goes up to one and actually logs out. They stay open. And that's one of the ways that we can make sure that, again, it's a confirmation of control. So we're going to switch gears now, and we're going to talk about supply chain. So we have confirmation control on the authentication side. We also have to make sure that these very complex devices that we manufacture, that they are genuine Schneider Electric devices, they're providing genuine data to our cloud applications, and that they have a genuine firmware loaded on genuine hardware so that when something bad happens on the electrical network, they do their job. One of the challenges we have is that we have a lot of different vendors in play, and then we have multiple facilities in the assembly and manufacturing chain. And we need to be able to secure from the point the secure microcontroller is developed and initialized all the way through final assembly. And you can see the trucks there on the screen. That secure microcontroller is going to be implanted into a PCB, right? It's going to be loaded with some test firmware. It's going to be loaded into a chassis for the circuit breaker. And then finally, it's going to go through testing processes. How do we secure that? And that's where we came across the UBHSM. The UBHSM, at least this is the solution we came up with. It's in use today. We work with the vendors of our secure microcontrollers. They have a UBHSM that we have provided to them. They have a secure server with that infrastructure within their manufacturing facility, literally at the silicon, when they're creating the secure microcontroller. We provide them with some test firmware that they load onto the secure microcontroller, and then they lock the microcontroller to where it can't be used. It's totally locked down. The secure boot process is locked down using synchronous keys that are then exchanged to us using the UBHSM to encrypt those keys. That secure microcontroller now goes through the rest of the process. Remember, it's using a temporary firmware, so it gets implanted into the board or chip select. They place it on the board, solder it in, all the other components. Throughout this process, that test firmware is available for testing the end device. And then finally, when it gets to assembly at the Schneider Electric manufacturing assembly at a secure location, those keys are then exchanged via the UBHSM with that encryption, and then we unlock the device right prior to final testing and then shipment. So we know through this process at least two things: that we're in control of all the secure microcontrollers that have been developed for us and that have been loaded with our genuine firmware. We're also certain that it has genuine firmware because we're doing that. We're loading it at the very last point of the process right before delivery, right? And we're sure that nothing was injected into that microcontroller before it gets into final assembly, before it gets shipped to the customer. So that's how we're using UBHSM to actually exchange those keys between multiple parties from a wing-to-wing approach. So that's supply chain. Let's go to multi-factor authentication just for a second. This is another use case that we have at Schneider. We're really doing two things with Yubico, right? We're doing supply chain and multi-factor. Multi-factor is an interesting, this is actually how we got introduced to Yubico in the first place. Back in 2016 at Black Hat, walking through the vendor hall and run across a Yubico booth and start talking with Terry Schaffner over there, and he explains how Yubico works. And what really intrigued me was that they had all of this out in their community in open source. So the validation server to actually validate when you would press the button on the YubiKey, we could use that license-free, and we were able to recode it. In our case, it was into .NET. created our own library, implemented it into our products, and we didn't have to have any software on the client because it emulated a keyboard. It's like, hey, this is great. We're using a remote desktop. Like, all of this stuff started to come together. So we ended up taking their validation software, recoding it in our language of choice. We built it into our libraries within our SCADA system, and this is currently in use. There's utilities and manufacturing plants, healthcare facilities, data centers across the world using this. And it coordinates with Active Directory. The YubiKey is actually programmed by our software, again, using code that they provided from their community, and then we recoded into .NET. And some of the challenges that we faced, the big one was synchronization, secure synchronization, because we have two servers. We have a primary and a standby for failover, right? Makes sense, critical infrastructure. We need to be able to program the key in one, but have it work across both. It sounds kind of simple on the surface. When you start digging into the details and talking about key exchange, it gets pretty interesting. So that's one of the things we had to overcome. It was something we were able to solve. And again, that's how we did it. And I think that is my part of the deck to go to you,
so I was going to ask you some questions.
Okay, ask me some questions.
That was like a lot of history,
Yep.
a lot of what we did, a lot of sort of pre-FIDO.
Pre-FIDO, absolutely.
But there's some lessons learned, like you said, about
Yeah.
leveraging systems that don't have to load software and being able to leverage sort of a pseudo standard because this was ours. But now, what is driving you to move to FIDO?
Yeah,
FIDO standard?
yeah, good one. Okay, so if we think about what we're using today, we're using what's called UBOTP, right? So UBOTP, it's the emulation of a keyboard and it's sending a simple string, which makes it very, very flexible for us. We can do that over a web client, desktop client, et cetera. However, that's not an industry standard approach for us. There's also a design vulnerability that's around phishing, right? So it is possible to take an OTP and phish. There's no challenge response in that because it's a one-way, you're sending that string across and it gets validated. There's no time element to it. So there's that. That in itself also presents challenges to us when we want to move to something that is challenge response, right? That has that bidirectional communication because that knocks out the ability to use RDP with a HID or with keyboard emulation, right? Because we don't have that bidirectional capability. The other challenge with UBOTP is that synchronization that we mentioned. If we go to a FIDO style of approach, we're not going to be synchronizing within our libraries because that would be handled by the FIDO infrastructure, I think. So that's the two primary things there, which I know I ran into a little bit of the lessons here on how
So what
this would be
MFA
hard.
lessons
have
you learned from the impact for your FIDO efforts? Because it's like there's a lot of blood and tears that you've probably done to make this work in that very complex environment.
That's right. So with UBOTP, this was pretty seamless across all of our clients as far as our thick client, web client, et cetera. We know with FIDO it's going to be a bit more challenging because we have mobile clients, we have web clients, et cetera, and we have to do all of this challenge response. So some of the lessons, we've got to get the synchronization right up front. We've also got to get the transition right. And I think, again, I'm blending in if you want to go on to the third one. So if there's anything the industry can do to help the OT side or the OT customer base to transition to FIDO from these more legacy approaches, that's where we're going to get wider acceptance. There's a lot of different things to factor here. You think about some of these systems we have out in the wild that have been there for 20 years. When we design devices, we expect 10+ year lifespans. Now compare that to your typical even network appliances, routers and switches and firewalls, et cetera. What do you typically see for lifespans, right? 3, 5, 7 years before those things are obsolete and you're replacing them. With power meters and circuit breakers, et cetera, we have to see a 10-year plus range because you don't have these maintenance windows. Imagine your utility calls and says, we're going to take a substation offline and your house is going to be out of power for a number of hours so they can replace this gear. You don't really see that very often, so it's harder to go in and replace that gear. So as a result, we have to figure out strategies to allow that transition into a more challenge response-based architecture.
I guess one thing we didn't talk about too much, but maybe you can expound a little bit on sort of the operating system level. So with FIDO, it's standard across the industry, which is great between the RPs and the platforms.
Yeah.
But what challenge does that bring within an OT environment?
Yeah, good one. So if you think about how the user interacts with the typical computer, right? In the IT world, they use it within their own user context. They log into the operating system. They may log into applications, et cetera. Where in the OT side, typically they're logging into the application. They're not logging out of the operating system. Okay, so the user context is typically a system level context as far as the operating system is concerned. So what that means, all of that to say that it has to operate standalone from the operating system as well as integrate with the operating system, because we still have to abide by all of those policies. It's part of the 62443 standard about password expiration, minimum lifetime, maximum lifetime, the list goes on. And we leverage Active Directory, Radius, et cetera, to do that. Okay? But what we can't do is depend on it wholeheartedly. It has to be able to operate in a standalone environment, inside and outside of Active Directory, for instance, which makes it to where we need something flexible enough that it doesn't have all of these larger dependencies. So you're going to have the same system deployed in a large data center that may have thousands of power devices, for instance. That same infrastructure needs to fit in a substation that may have 10 devices. Right? You're not going to have a server closet with Active Directory, domain controllers, et cetera. Instead, you're going to have a DIN rail mounted industrial PC that's, it's made for high temperature environments, et cetera. So your infrastructure has to be able to scale. Okay. Hope that answered the question.
And I think not everything runs on the latest operating systems.
Yeah,
or they're very unique, right?
Right. Yeah, the maintenance window is so small or non-existent in some cases. We, of course, promote updating to the latest updates, and we can only do so much as vendors. Our goal is to have all the latest updates on all of our customer systems, and we certainly get them to update whenever there's a security vulnerability.
Great. Those were the set of questions. We have about 2 minutes left. Is there any question from the audience?
Happy to. Yeah, go ahead.
There was one image you showed of an operator using a Yubico key.
Yeah.
And we said periodically we have to verify that the correct owner is wielding the key.
Good one. Yeah.
So how do you do that?
Yeah, good
Could
one.
you
So,
repeat that question real quick? So
yeah, I can do that. So we were talking before. Let me go back to that slide actually. And I think, okay.
You talk.
Yeah. So if you think about the normal operation of a SCADA system, we're talking about SCADA systems predominantly in that example. These control environments, these screens will remain open because they need to be able to see alarms coming in. They want to see the state of their system at a moment's glance. So you're not going to hit Windows L and lock the machine and walk away from it. Instead, it's going to remain open. So many times what they'll do is set it up so that any time a control action is executed on that software, it prompts the user for additional authentication. And that's where the YubiKey would come into play. So you would be able to get to everything unauthenticated, if you will, as far as reading the data, because you're in a secure environment. You're in a locked room, right? So everyone's allowed to read it. But we want to make sure we know who actually does an action, who takes action, who opens and closes a breaker, for instance, for auditing reasons, security reasons, safety reasons. So that's where when they open or close the breaker, before it commits that action, it's going to require them to press the button. Does that answer your question? Perfect.
So I just want to, we're out of time. But the main thing is that we're seeing that there is this huge requirement to go to phishing-resistant MFA in this space. Absolutely, knowing the risk that happened to infrastructure systems. So it's critical. But at the same time, there's a lot of things that are hard to do. But we know that this audience is super smart and can help solve them by the end of the week. And we would love to talk to you about that. Absolutely. And how after this, or even tonight, just come ask us questions, because this is a complex area to deal with.
Yeah, I'm around the conference. I'd love to talk. Yep.
Okay, thank you.
Thanks, everybody.